Here is an order book. Bids on the left, ascending asks on the right, best prices on the inside, everything neatly sorted. It looks completely healthy, and it may be entirely wrong. Sorting proves nothing about currency. If one update never arrived, this book is a confident picture of a market that no longer exists. So the useful output is not just prices and sizes. It is the state plus the evidence. Which sequence anchored it, how many updates were applied, which were discarded, and whether anything was rejected. A snapshot is a sequence-anchored starting state, not a timeless truth. In this tutorial, we will do 4 things. First, freeze the input contract so that price, sequence, clocks, and quantity semantics all mean exactly one thing. Second, step through one small synthetic feed by hand. A snapshot plus 24 incremental updates applied in order. Third, break it on purpose with a stale replay row, a missing sequence, and an impossible quantity, and watch the reconstruction refuse instead of guess. Fourth, verify that the result matches a frozen expected output in both reference implementations. The complete article, source code, and interactive playground are on the fintechbuilder.com, linked in the description. Before any code, freeze 5 dimensions. Price is integer ticks with a declared scale, never a floating point key, because a book is a dictionary and its keys must be exact. Sequence lives in one documented session, so gaps and anchors are testable. Event time and receive time stay separate, so arrival never impersonates venue causality. Quantity semantics are selected, not assumed. And every invalid state is handled explicitly. Reject, buffer, recover, or exclude. This adapter uses absolute replacement quantities. A feed that publishes signed changes or actions on level indexes is a different adapter, not a tweak to this one. Start with the snapshot. It carries 5 bid levels and 5 ask levels, and it is stamped with sequence 500. That stamp is the whole point. It does not say this book is true now. It says this book was true through sequence 500. The best bid is 10,000 ticks with 20 units resting. The best ask is 10,002 with 18. Nothing sits between them, so the book is not crossed. From here, the rule is exact. The next update we accept must be sequence 501. Anything at or before the anchor is already contained in this state. Sequence 501 arrives, bid side, price 10,000, quantity 12. Under this contract, that 12 is not a change of 12. It is the new total resting at that price. The level held 20, now it holds 12. Right? Do not add. If you treated the same message as a sign delta, you would compute 32 and publish a book that is wrong at the top of the bid side on the very first update with no error anywhere. That is the whole reason quantity semantics belong in the contract. The rule is one line. Quantity at a side and price is a replacement, and 0 removes the level. Now the deletion boundary. At sequence 510, the ask at 10,006 is published with quantity 0. 0 is not a level holding nothing. It is an instruction to remove the key entirely. The same thing happens on the bid side at 517. The bid at 9,999 disappears. But deletion is not permanent. At sequence 524, 10,006 comes back with 18 units. A price level is a key in a map, not a slot in a fixed grid. It exists exactly when the last accepted update for it was non-zero. Run all 24 updates and the book settles. 500 plus 24 contiguous updates gives a last sequence of 524. That is the independent arithmetic check. Applied count is 24, discarded count is 0. The bid side now holds 6 levels, topped by 10,000 with 17 units. The ask side holds 7, topped by 10,002 with 24. Best bid is below best ask, so the book is still uncrossed and the state is marked current. Notice the book grew. The feed added levels below and above the original range and removed one on each side. Real feeds replay. Suppose the stream also delivers sequence 499 and sequence 500, both at prices this book has never seen. They are not corruption and they are not a gap. They're already contained in the snapshot because the anchor says this state is valid through 500. So they are discarded, and the count of discarded rows becomes 2. Everything from 501 forward applies exactly as before, and the final book is byte for byte identical. That is the difference between a duplicate and a whole. One is safely ignorable, the other is not. Now the dangerous one. The stream runs cleanly to sequence 508. Then the next message is 510. 509 never arrived. We do not know what it said. It might have deleted the best bid or have the top of book. Applying 510 anyway would produce a perfectly sorted book that no longer corresponds to any real market state, and nothing downstream would ever notice. So the reconstruction stops and says exactly what happened. Sequence gap, expected 509, received 510. The state is rejected. A sorted-looking book is not current if one sequence is missing. 2 more refusals. A quantity of -1 is not a small book that owes shares. It is a decoding or adapter error, so the reconstruction rejects with quantity must be greater than or equal to 0. And after every update, the top of book is checked. If the best bid ever ends up above the best ask, the reconstruction raises a crossed book instead of publishing it. In all 3 refusals, the previous valid state is never quietly overwritten by the bad input. That is the discipline. An unsafe state is rejected, buffered for recovery, or excluded with a reason, but it is never silently absorbed. This is why the output carries diagnostics beside the levels. The snapshot anchor says where the chain began. The last applied sequence says how far it reached. Applied and discarded counts say what the stream actually contained. Best bid and best ask expose the inside of the book at glance. And the state field says current or names the refusal. An interface that returns only prices and sizes forces every downstream consumer to guess whether the state is fresh. Returning the evidence beside the values means a caller can decide rather than assume. The code follows that order exactly. Start from the anchor, build the book from the snapshot, and set the expected next sequence. For each incoming update, discard anything at or before the anchor, and stop on anything that is not the expected sequence. Then apply the transition. A non-zero quantity writes the level, and a 0 removes the key. Finally, sort both sides, check the top of book, and return values and diagnostics in one object. It is deliberately explicit. It does not optimize away the checks, and it does not mutate the caller's input. Verification means 4 surfaces agreeing. The frozen expected output file, the Python implementation, the TypeScript implementation, and the independent arithmetic line all produce the same final book, the same last sequence of 524, and the same applied count of 24. That is what the tests prove: canonical arithmetic, invalid state rejection, and parity between the 2 languages. It is equally important to say what they do not prove. They say nothing about feed uptime, nothing about latency, and nothing about prediction, execution quality, or profitability. Correct reconstruction is a precondition for analysis, not a result. Reconstructed levels are inputs to real microstructure work: order book slope, depth weighted mid-price, and the measures built on them. But that handoff is conditional. Those consumers may read this state only while sequence continuity is intact. A book that is recovering from a gap or drifting from its source must be blocked at the boundary rather than quietly measured. This keeps 2 concerns apart. Feed correctness is a data engineering problem with sequences and clocks. Economic interpretation is a different problem. A slope or an imbalance measure is not a data cleaning tool, and it cannot repair a book that was never current. So keep 5 things visible at all times. Identity, so you know which instrument and venue this book belongs to. Sequence, so the causal chain is contiguous and testable. Clocks, kept separate, so arrival never impersonates the venue. Quantity semantics, selected explicitly because replacement and sign change look identical on the wire. And unsafe state handling, so nothing plausible is ever published without support. That is what turns a stream of decoded messages into auditable market state. The complete article, both implementations, the frozen fixtures, and the interactive playground are on the fintechbuilder.com. Link below. Continue the learning path at the fintechbuilder.com, with a full order book feed articles, source code, visuals, and playgrounds carry this state into order book slope and depth weighted mid-price.